So I posted some things on Avenue to Learn. Can you download the images, okay? So let me quickly recap. What have we done? Now over here, what you see is what you see over here is rigid body. Under linear translation motion. Okay. So there are three equations. So what does it mean by linear translation? So i.e. Omega and alpha are equal to 0. So the rigid body is not rotating. So the past two example that we did, right? The rigid body, one is a car, the other one is a crane. They're not rotating at all. Okay. When this is the case, when we have our transformation, this is x and this is y. We have it as summation of forces, so positive going towards the left. Summation about forces in the x direction is equal to m and a g about x. And the next one we use is summation about forces in the y direction is equal to m a g y. Then we take about moment. Summation about moment at the where? At the center of gravity, this is equal to 0. So over here, this is at center of gravity. Or another word, point G. Okay. Now, if by any means you also, if you want to do this at about point D, right? Or we want to take moment about Z, sorry, not point D, at point A, right? So we want to take the moment of point A. Now, this will not be equal to 0. This will be equal to M multiplied by AG, and then you have to multiply by a distance D. So you all saw that happen yesterday, right? Remember yesterday? I'm trying to tell you what. Yesterday we did an example over here. I'll let you guys finish copying first. Did I tell you guys McMaster by mistake ask people who wants to attend an event on throwing X? Did I tell you about this? So I was sent an email by the Faculty of Engineering. Are you interested to attend an event on throwing X? And my reply is, if I can choose who I can throw the X to, I'll say yes, otherwise no. You know what? After that, I got about 10, 15 emails inviting me to go to throw X. Some of you got the humor, the rest, what you have. Anyway, right. So yesterday, don't worry, I went through X at you. I love your question yesterday, okay? Okay, now, so yesterday I showed this, right? I showed this effect, right? Remember, we take moment about point G. Can you remember this, right? Yesterday, we take we take moment about point G. This is equal to 0. And then we solve it differently. Did we solve it differently? Yeah, we solve it differently, right? We take moment at point A. Can you all see that? So this side is not equal to what? 0. We did that yesterday. And the answer is the what? Is the same. I need you all to have the confidence. Regardless of where you take the moment, the outcome, the answer will be the same. Now, which other course is the same, take the same philosophy? 2 P04, yes or no? Right? You can take moment about where? Anyway. Are we clear? The answer should be the what? Should be the same. Usually in 2P, you take the moment where you have what? The unknown. Are we clear? Okay. Likewise for this, it's the same thing. Right. The next one that we are going to consider now. Okay, we are going to consider equation of motion. For curvilinear bloody hell. Okay, curvilinear translation. Okay, so what do we mean by curvilinear translation? So this diagram over here that you see now is a curvilinear translation. Okay, so for curvilinear translation, what you see is the entire rigid body is going through a curved path. Can you see this? This is Eugene, come on, seriously? Going through a curved path, as you can see down here. However, likewise, omega and alpha are equal to what? 0. Okay, so what will happen if you have a structure in this sort of configuration? So under curvilinear translation, right? It is best to use the N and T coordinate. Okay. So for this case, what you see is the structure. So for example, the structure is going in this direction. Okay. So when that's the case, we always label the tangential direction as T, and the one pointing towards the center of curvature, we call it as what? N. Are we clear? Okay. So we use the N and T coordinate. So from here, some mention about, so you can draw this, okay, towards the center. Summation of forces in the N direction, this will be equal to M multiplied by AGN. Okay. And then you have summation of forces in T. This is equal to MAGT. Okay. Now, if you were to take this summation about moment at point G, then the whole thing will be equal to what? Will be equal to 0. However, if you decide to take summation about moment at point B, where's point B? Okay, so I want you all to draw the attention to the figure over here. This location is our what? Our point B. So we decide to take moment at point B. When that's the case, what we have will be equal to what? MAGT Then we are going to multiply AGT multiplied by E. And then after that, minus MAGN multiplied by H. The plus and the minus over here is dependent on the moment, whether is it rotating clockwise or counterclockwise. Are we clear? Yes. Okay. So again, either you take from the center of gravity or from point B. What am I going to say? The answer will be the what? Same. Okay. I need you to have the level of confidence. Are we clear? Okay. Yes.
Negative tangential that changes based on clockwise or counterclockwise. In the normal direction, always.
It's up to you what you want to specify down here. Okay, what you specify down here. Okay, so it's wrong, the direction is wrong. Okay, now let's look at an example. Okay, let's look at example over here. And this is on Avenue to Learn. At the instant shown, link CD rotates with an angular velocity of omega CD is equal to 8 radians per second. If the link CD is subjected to a moment, upward moment of 650 pound-feet, determine the force developed in the link AB and the angular acceleration of the link at the instant. Neglect the weights of the links and the platform. The crater weighs 150 pounds and is fully secured onto the platform. This is what the solution manual provides. Okay, I want you to highlight this. So I want you now the solution, the people that do the solution manual, I'm not saying that they are dumb. Okay, but I want you to become critical thinkers. Okay, I want you to become critical thinkers. And I want you to apply static analysis. Okay, I want you to think about static analysis. So you can see that the structure has a weight. Right? You can see that the structure has a weight. What is wrong? The free body diagram. Eh?
Like if that was it's the reaction for
Yeah, but what's interesting now? Let me ask you a simple question. Using static analysis, the seat members CD should be under tension or compression. Let's look static first. Tension or compression? Compression. What did they draw? Tension. Tension. Does it make any sense? No. Right? And how they construct, and you're right. The way they construct the right hand free body fluid diagram, the reaction at DA and FAD, should it be going up or coming down? It should be going up, yes or no? Right? So what I'm trying to teach down here is I want you to apply what you learned in what? Statics. This is completely what? Opposite. Right? This Dr. Koshi's course is a pass, the course is a fail. You get me? No, we should be able to apply the same one principle. So we're going to construct a free body diagram that we're going to throw this out the window. So when I post the solution, you'll see the solution member.
No, it has to be.
What?
No.